So to round out the attributes chapter, I just want to take a little bit more of a dive into an example that will allow us to maybe just get a little bit more comfortable with our VOPS networks, before we proceed on to the next chapters and stuff like that. So in this lesson, we're going to be building a random effector like setup. Now, Houdini might not be your number one choice for doing, cloner effector type stuff, but I think that either way, it's like important to sometimes build, things for yourself that you would be more comfortable using in another program like Cinema 4D, for example, just to sort of get a feel for how things in Houdini work. So whether having a effector set up in Houdini is really something you're after or not, I still think there's something to be gained by seeing the VOPS workflow one more time and just sort of trying to get a little bit more familiar with it, because we will be using all this stuff a lot later on in our as we go through the course. So let's start by creating a better fall off. Up until this point, we've been creating most of our attributes fall offs using an attribute transfer, which is totally great. In this example, I want to use a sign distance field fall off so that we can use something other than just a point with a fall off from it. So let's start by creating we'll be creating a grid. So I'm going to throw down a grid. And then I'm going to dive inside, and let's give our grid a little bit more subdivisions. I'm just going to go up to 50 and 50. So now that we have a grid, I want to create an object so that we can get a little bit of, we can create an object to be our fall off. So let's throw down, I'm just going to throw down the rubber toy test geometry, and I'll just template the grid. And yeah, I think that where the rubber toy is right now is great. Its feet are sort of, sticking out into this grid a little bit, so we can get just something more of an irregular shape. I'm just going to bring the scale up a little bit, and it looks like those feet kind of sunk down. So maybe I'll just translate it up by, let's see. Maybe I'll translate it up by 0.5. So it's a scale of 2 and a translation of 0.5. So there it is. And now what I'm going to do is create a sign distance field out of this. So I'm going to do that by doing VDB from polygons. VDB from polygons will create a SDF for me, which is represented like so. And you can see it's created my surface here, and I've got my voxel size. I want to fill the interior, and then we've got our exterior band voxels, which will help us determine how far away from our object we're having our fall off extend. So what I could do is I could actually use an attribute VOP to look up what my sign distance value is from the surface. And sign distance functions will actually tell us, based off of how far away we are from this object surface, it'll give us a distance. So if we're outside of the object, we'll get positive values, and if we're inside the object, we'll get negative values. Which is a really cool feature that we can do much more than just this with. We can use it to create containment forces and all sorts of awesome stuff. So what I'll do is throw down an attribute VOP, like so. And then in our first input, I'm going to wire in the grid. And in the second input, I'm going to wire in the VDB from polygons. So now we just have our grid, and I'm going to dive inside here. And we're going to do a volume sample. So basically what this is going to do is we're going to take our second input into our volume sample, and you can access the second input of this VOP up here by looking at this second input, op input 2 right here. So I'm just going to pipe that into the file name, and then the position that we want to sample it at are at each one of these points in our geometry, and that attribute is just simply P. So I'm going to wire in sample position, and then I'm going to just write this out to a new attribute we're going to create called the fall off attribute. So I'm just going to do a bind export, and we don't even have a fall off attribute yet. But if I write fall off here, and I wire this in, and we hop up here, that's just effectively like creating the attribute. So middle mousing over our attribute VOP, you can see that the fall off attribute is created right there. I can't really click on it while I'm holding down the middle mouse button, but if I go over here and hit this info button, it pops this window up, and then I can actually move my mouse around over it. Then if I click on fall off, you can see that it actually will create a visualizer for me. And to demonstrate the numbering system of how sign distance fields work, I'm actually going to change the way this visualizer works. So right here, this icon for our visualization, you can see it's created into a fall off visualizer for us. I'm just going to hit the edit button. And instead of doing a color type visualizer, I want to switch it to a marker. And now our marker is displaying numbers. I'm just going to increase the size of these numbers to make it a little bit easier to see. Cool. So you can see if I template the test geometry that numbers that are inside the geometry, so if you see this edge right here, it's kind of hard to see, but right here, numbers to the left inside the geometry are negative, and to the right, they're positive up until a point, and then they eventually just cap out at 0.3. And if we look at this, 0.3, what is that? That's a distance, and that distance happens to be 3 of the voxel size. That's because there's 3 exterior band voxels of this size. So if I increase that, you can see that that fall off distance is changing. These numbers that are larger, these numbers with extra decimal points basically are changing. And we could actually use this because we want our fall off attribute to actually be 1 on the inside of this object, and we want it to fall off to 0 outside the object. So we could use a fit range again in here. And what we're going to do is we're actually going to use the fit range, and then we're going to use the fit range to actually drive this distance for the distance for our exterior band voxels to make sure it extends to a distance that we want. So let's go inside here, and first we're going to just use the fit range. So I'm going to type fit range and drop this in between these 2 nodes. And you can see now that it is clamped off the input of the interior to 0. So it's sort of maxing out there. Now what I want to do is say, given our source max, I want to feed in a value to our source maximum that will tell it to fall off to 0. And it will tell this to fall off to 0 because we're going to fit this between 1 and 0, but it's also we're going to use a relative parameter reference to drive our VDB from polygons. So here, because we want it to be 1 inside and 0 outside, I'm just going to switch this destination min and max around. So I'm going to make destination min 1, and then destination max is actually going to be 0. So we're going from a value of 1 now, and it's decreasing to, right now, it's 0.7. So if I create a parameter here, I'm going to make this parameter drive the source maximum value, and we're just going to hop. I'm gonna name this fall off distance, and I'll give it a label of fall off distance like that. So let's hop up here, and you can see that down here it's created our fall off distance attribute for us. Now if I increase this, you can see that it's doing something, but what we actually want to do is, because it's reading in this volume sample over here, it's not quite hooked up right. You can see it's kind of jumping all over the place and not really doing what we would expect. So what I'm going to do is I'm going to actually copy this parameter. So I've got this parameter copied. Now if I go back to the VDB from polygons, I can determine how many exterior band voxels I will need to satisfy this fall off distance if I just do a simple division here. So I'm going to take I'm gonna select this value. I'm going to right click and paste relative references. So again, that's I right click copied here, copy parameter, and then I went over here and said right click paste relative references like so, and then we just need to divide that by the voxel size. So I'm just going to right click this one, copy parameter, insert a slash here for divide, and right click paste relative references. And now you can see that if I were to give this a, let's see, our grid goes all the way out to, it looks like our grid's 10 by 10. So out here is a width of 5. So I'm going to just increase our fall off distance to 5, and hopefully that should reach to the ends of our thing. And now it's not quite going to reach the end just because this isn't our object isn't at 0. So if I just bring this down a little bit, something like, whoops, something like, you can see, I'm going to bring this back to, let's bring it back to 1 real quick. I just want to double check something. Oh, this is something that happened to me too. Because it's using voxels and interpolating, see how it kind of has an issue right here? It's having a little bit of a problem interpolating between values. Just to illustrate this a little bit better, I'm going to just bring up, I'm going to change the visualization back to a color. So we get this red fall off. And you can see that when I modify this fall off distance, sometimes it pulses red and then goes back. And that's because it's actually, like when it reaches its minimum, it's sampling a value, like a minimum value there. It's sampling a value that's between like these colors right here, right there. So one way I found to get around that was just going to do a little bit of trickery over here on the formula for my exterior band voxels. So I'm going to just add 1 here. And now if I increase this fall off distance, you can see that it doesn't ever pulse red. The reason why this works is because I'm actually allowing this exterior band to be a little bit further than this fall off distance. That way it just has a little bit more to work with, and it doesn't have to round to some in-between value. So doing that now, if I throw it on a box, let's just throw it on a box that is, like, you know, a size of 3. And I'm just going to bring up that, and I'm going to also template. If I hold down Shift, I can template 2 objects together. Let's go into our top view. I'm going to grab the box and grab the manipulator. I'm going to move the box to the end of this wing. So now when I increase my fall off distance, this red value should just reach out to the tip of this box. So if I go up here and increase the scale of that to 3, we can see that that's looking like it's getting pretty close there for the for determining our fall off range. So that is how I was able to get this to this kind of fall off to work with sort of any shape that I want. One other sort of you know, kind of bulletproofing thing that I want to do here to make this system work is I just want to, if I illustrate here, if I go and bring my fall off distance down to 0, everything goes red, and I don't necessarily want that. There might be situations where I would bring this fall off distance down, and I just want it to be inside the object, and I want it to have a really harsh fall off. So I'm going to just protect against it going all the way to full red by just diving in here. And I'm going to just do a simple maximum evaluation on this distance parameter. So what I'll do is I'll use a maximum node, which will basically allow me to say, you know, I want to have, I don't ever want this to truly go to 0. I want this node to read both inputs and choose the larger of the two. So if I put in a constant is almost like a parameter, except that you can't adjust it from up above. It doesn't create a constant parameter up here for us to manipulate. It's sort of locked inside of our VOP, which is cool because we really don't need to mess with this at all. So I'm going to set this float value to 0.0001, just a value that is insanely small that we're never going to really want to use anyways. And if we did, we could just jump inside and edit this, but for our purposes, this should work great. So now when my when my now, because this maximum is reading, I want to know, if this value goes below 0, it's just going to switch off and turn on this float default of 0.0001. So it's just a little protection we enabled in there. So we can actually drag our fall off distance off and then down to 0, and everything works accordingly. So that's cool. So the next thing I want to do, just to make this fall off a little bit more functional, is just to add an actual fall off ramp, so that we can actually determine the shape of our ramp instead of just a linear sort of fall off the way we currently have it. So what I'll do is I'm going to go up here and edit my parameter interface, and I just want to get rid of these two folders and just make them invisible, so that I have a little bit more space up here to look at this. So that just kind of cleans this up here. So when I get inside, I just need to throw down a parameter, or a ramp parameter now. So it's as simple as this. Just type in ramp parameter, and we'll bring it in after our fit, because we've fit our values between 1 and 0, which is what we want. We got a ramp parameter here. And it's by default, it's a color ramp. I just want a spline ramp. And then we can just, I'll just name this something relevant, like I'll just name this ramp first off, and then I'll just name the label fall off shape. Cool. And we'll go up to our attribute VOP here, and you can see that the ramp isn't working because it is set to 0 by default. So I just turn this up. I'm just going to get rid of that last knot here, and now we can determine the shape of our fall off however we want. So for example, just to see this thing in action, I'm going to temporarily just wire our fall off into let's do the trick where we add the value. I'm going to do this in a different VOP though. I'm going to throw down an attribute VOP. Attrib VOP there. And we're just going to dive inside. I'm going to get the vector to float. This option, and then a float to vector. Like that, and then I'm going to bind. I'm going to bind in my fall off because it's not in my main list over here. I'm going to wire in the I'm going to actually call it fall off because I gotta actually name this here according to what we had created back here. So in here, I'm going to take the position. I'm going to break the position out into its X, Y, and Z components. I'm going to pass through the X and Y components, and then instead of the Z component that it originally had, I'm just going to wire in our fall off and then wire that to position, so we can see that sort of fall off. And like right now, it's basically linear because of the way that this is set up. But now I can add additional points and change that. So let's I'm going to grab these 2 points, and I'm going to change their interpolation to B spline. I did that again by just clicking this first knot down here, and then shift clicking this second knot over here, and then just selecting B spline here. And now when I add points in, it'll be nice and curved. And you can see you can modify your fall off shape however you like. So I'm going to just do sort of an exponential one like this for right now, something that's just got a little bit more interesting of a slope to it. And some decay towards the edge. So now, if I were to, grab this rubber toy, and maybe actually to make it a little bit easier to see, I'm going to just, let's just maybe bring these 2 values down. So just shift click both of those, and I'm bringing them back a little bit. So now if I were to move this toy around, maybe by throwing a transform underneath it, like so. Now, wherever I move this transform, it is, appropriately falling off and doing all those things that we were hoping that it would do. I'm just going to undo out of that real quick. And, you know, another thing to make note of is this voxel size. There will be instances where we maybe won't need quite so many voxels. If we don't need that much resolution or we're trying to gain some additional performance, we could actually increase the voxel size to a resolution that is working better for us. You know, something that would be more performing a little bit higher. And see, it decreases because of our math that we had done before. It decreases our exterior band voxels by quite a bit, and a large number of exterior band voxels can get a little bit slow. So it's just important to note that. Now it seems like it's performing much faster when I when I move this object around. Cool. So now what I want to do is now that we've got that out of the way, let's start building our random effector. So the way that we're going to control our random effector is we want to control random position, scale, and rotation. Those are the three parameters that I'm really just concerned with for this example. I'm going to just put my highlight flag on here. I want to name my fall off accordingly, so I'm just going to call this fall off. And then we're going to start by just adding, let's just start by first adding our random position for each of our points. Then we can add a scaling factor to that random position. So let's go in here and create another attribute box. And if we go inside in here, we can start building this. So we've got our positions, so we can modify our positions. We also have what other attributes? We've got a point number attribute. This is a unique ID number for each one of our points. And if I open up my attribute spreadsheet, I'm just going to split this scene view top bottom and right click here and add my geometry spreadsheet. So if I bring this down here, you can see that this number on the left is our point number. We can use that as a random seed. So let's create a random vector that will offset and displace our points on this grid depending on the fall off. So we're going to need to create a random number. We can do that using a random node. So random, and then I can wire in for the random, I can wire in the point number like so. And you see that the random has an option for 1D integer input and then a 1D output. So it's taking this one-dimensional integer input as its seed value and then creating basically a number from 0 to 1. Now that won't really work for position. If I wire this and we just add this random to our position, if I just wire this into position, you can see that everything kind of goes away. It's because it's all being sort of collapsed in on itself because this isn't a vector. Position actually is a vector. So if I take this and I actually have this random function create a vector for us. So I'm going to say instead of 1D integer 1D output, we're going to do a 3D vector output. And now you can see that it has made a bunch of jumbled mess in the range of 0 to 1. So inside of this grid, I just got to get up here and get this box out of here. Don't need that anymore. It was for demonstration purposes. But you can see that it has created a box for us that is resting in between 0 and 1. And if I jump to, you can see that all these random values that it generated for these vectors lie between 0 and 1. So that's funny because, you know, it's doing the random thing for us, but it's not exactly none of these points have retained their original position. And this is just one of those things you got to get used to, is that when you generate just a random number, it's going to give you a random number between 0 and 1. You don't actually want to make that the new position. You want to add that to the position. So we're just going to throw down an add node, and I'm going to take our original position and add this random amount to that position, and then pipe that into the position output. And there you can see that now, whoops, if we go back to our original view, here I just hit spacebar 1 to go back to our normal view here. It has added like all of this stuff, but our grid is still relatively in the same position. We've just been adding this random amount to it. So we definitely don't want this much randomness, and we want it to be centered about our fall off. So what we could do is actually drive the effect of this to, we could drive the effect of this random vector by multiplying it by our fall off. So let's bring in our fall off. Oh, oops, there isn't a fall off node. I actually have to bind import the attribute we created called fall off. So we're just going to call this fall off here. So that way it's fetching our attribute. And I'm going to just throw down a multiply. And I just want to multiply this random vector that was generated by that fall off. So I'm just going to throw the multiply right here. And I'm going to wire in the fall off. Cool. So an important thing to note at this point is that if I were to hit Shift R and reverse these around, this multiply is doing something really funny if it's taking in this scalar float value first. Because this random is generating a vector and we want to scale that vector, we need to feed the multiply the vector first in order for it to do that. And this just goes to, this is sort of like a I think it's like a linear algebra type vector multiplication concept, but color coordinated wise, our random is generating a vector which is green, and these are sort of this teal color. We actually want the green to go in first. You see how it changes this color, and then this color in this output to green. And now if I wire fall off into the second input, we get a truly random non-directional type of noise happening here. Cool. So the next thing I want to do here is, now maybe we could get a parameter out here on our effector controls that would allow us to determine like how much scale is going to fetch, like how much is going to offset these points along each axis. So let's create another parameter down here. First, before I do that, I'm going to do the same thing. And here on my attribute font, I'm going to edit parameter interface, collapse the vex setup and the attribute bindings, and make them invisible just to make it so I have a little bit more real estate up here when I'm building my parameters out. So simple. I just want to multiply this random number by a parameter that I create on my own. So I'm going to create a param, and I'm just going to throw this into the third multiply slot, and I can just call this my position scale. For my random position scale effect, like what the scale of the effect is on position. I guess that doesn't make sense because I'm going to want to add one for scale as well. So I will just label this, maybe position effect. Yeah, I guess that works. So up here, you can see that it's only just a float value. That's not working. We actually need a vector, and I forgot to set that. So under our parameters, we select type. We want just our, where is it? Vector right here. So now when we go up, we get an X, Y, and Z value. So I can say, I want this to be randomly pushed in a bunch of different directions, only in the Y. So there you go. That's cool. And but one thing I'm noticing right now is that this is only actually pushing these positions up, and I actually want them to go both positive and negative. So what I can do is just simply use a fit range on our random function. So I'm going to just drag, select all these guys and drag them over a little bit. And I just want to put a fit range in here for this random function. So let's put in a fit. And you can see that because this is generating a vector, when we throw our fit down, we get a little bit different of an interface. Previously, we only had one of each of these, and now we have three. And that's just because it has a vector now. So it's smart enough to know that the signature is a 3D vector. Okay, so if I want these to go into the both negative and positive, I could just I've got our source mins coming from 0 to 1 because it's random. We know that. And then we can just remap the destination minimum to -1, -1, -1. And now we're truly getting truly random in all directions, not just the positive direction. So up here, we can scale this effect in X, or in Y, X, and Z. And the X and Z amounts don't really have too much of an effect until we start introducing something into the center channel. So if I right click and revert to defaults, then I can just middle mouse click on all these and sort of drag them. You can see that it's starting to gnarl things up there. Cool. Nice. So that's cool. We've sort of tackled how we can add some random positioning to our geometry. So the next thing I want to do is let's focus on the scale of our thing. So right now, each of these points don't really have scale. I mean, we've dealt with moving the position, but when we're going to later clone objects onto this, we want those objects that are cloned onto it to have some form of scale that's being randomized as well. And we can preemptively feed a scale attribute into our copy to points to get that random behavior. So let's just create our cloner first off. And I think I don't really need this anymore. I'm just gonna what was this again? This was just I was just viewing the Y position. I'm just gonna delete that. So I'm gonna just create a box here, and I'm going to make a copy to points here. And I'm just going to copy the box onto these points. And it looks like this box is pretty big, so I'm going to just decrease the size of that box, like so. I also, at this point, don't really need to see this visualizer that we had before. So if your visualizer icon isn't showing up here, you can actually middle mouse and scroll down, up and down this list on the side until you get to your little marker here. I'm just going to click it to turn it off. So you can see I've got my cubes are now randomly being displaced. I'm just going to add a little bit of animation to this at this point so we can see some stuff happening. I'm going to just grab I'm going to grab the rubber toy and bring it from right here, and we'll set a keyframe by option clicking the Z parameter here, and then I'll just go over to, let's say, frame 120, and I will drag this over here like so, and option click there. Actually, I think that's probably too many frames, so I'm just going to middle mouse drag this keyframe back to frame 72, and then I'll just set the end of my range to 72. And so now, as my rubber toy swims through this pond of cubes, it is moving them around. So that's cool. Now, one thing I'm noticing is that it looks like it does have a little bit of random rotation already to this object, and that's probably because it is trying to compute normals on the fly when it does this copy to points. So what I want to do is explicitly tell it whether I want these to rotate or not, and I also want to tell it about scale. We'll get back to the rotate part in a second. Right now, I just want to focus on scaling these particles accordingly. So to focus on that, let's just scale down our position effect to 0. I'm just going to right click and revert it to defaults again. So now there's literally no effect. And we'll just create another random scaling effect for for the scale of our cubes. And we will drive that using the p-scale attribute. The p-scale attribute doesn't exist yet, so we're going to create it using another bind export. So I got our bind export over here. I'm going to name this p-scale. And just to see it working here, if I wire the fall off directly into the p-scale, you can see it's already affecting the scale of our cubes in this area. Now, we don't want it to affect just in this way, but it's cool because we can see that p-scale is actually working and being read in by our copy to points. So let's just add some randomness to the scale as well. So I'll create another random, and this time I'm going to bring in the point number. and it reads in a 1D integer, and it's creating a 1D output. And for this example, we do want a 1D output. We're only scaling it uniformly. We could scale it differently along each axis. That could work. But for this example, maybe we do want to do it separately for each axis. Yeah, let's do it separately for each axis. I think that's like kind of how it worked in Cinema too. So we'll just we'll do a 3D output here. And now if I use a 3D vector here, now p-scale is just a uniform float that just scales it uniformly in each direction. So if I create a random vector, I need a different attribute. And the common attribute that is used in Houdini for scale is called, it's just called scale. So I'm just going to rename this one to scale. And it doesn't know what to do yet because we haven't given it a random. So I'm going to feed in this random vector into this random scale. And you can see that it is now scaling our cubes all in different, it's a non-uniform type scaling operation. It's changing depending on, it's different in each axis. So that adds a little bit more variety to our effector. So if we wanted uniform scale, we could use p-scale, or we could just do this. I'm going to also, what I want to do is, well, now that we see that our random function is working for all of this, for scale of attribute like globally, now we just need to multiply it by our fall off again. So I'm going to throw down a multiply. And I'm going to multiply the scale attribute, this random vector that was created here. I want to also multiply that by this. So you can see that it is now scaling our objects up from 0 to this amount. And really what I want to do is I want to, whoops, I accidentally copied that. I want to add this scale to our original object. But this is the thing, is I want to do it in a similar way that we did with position. I don't want it to scale perfectly. I don't want everything to scale up in some direction. I want it to either scale up or down. So I'm going to just, to make this happen, I'm going to just duplicate this fit range here. And I'm going to, let's actually take this bottom section. I'm just going to move it down a little bit so it's a little bit cleaner here. And maybe with this bind, I can, maybe I'll insert a little knot here to bring it down just so it's out of the way, and maybe another knot right here, just so we can keep everything sort of organized. So here we did a fit range where we did our source minimum was from 0 to 1. Well, that's the case that's also being generated by this one. So let's just let's use that as well. I'm going to wire this in, this random in here, and then I'm just going to grab this wire and pull it over here and wire it like so. So now it is doing a random scale in the positive and negative directions. And you can see that the effect of that, some of our cubes are turned inside out, hence this like slightly grayer color here, which is fine for right now. We don't really want that, but it shouldn't show up when we start adding it to our effector unless we go really extreme with it. So I'm going to just, what I want to do is add now this scale to our original scale. So we have our fit range here, and we're going to multiply it, and then I just want to add it to the original scale to begin with. So let's go in here and throw down an add. But what is it that we're actually going to add this to? Well, I think that in our to initialize, we don't have a scale attribute initialized anyways, but by default, everything is a scale of 1 because we haven't really changed anything. So here, I'm going to wire in another constant. We're going to create a constant here. And this should hold true for pretty much any situation. We're bringing in a object that has a scale that is undefined, but we know that if we multiply that scale by 1, that it will remain exactly what that scale was initially. So if we create a constant vector, like so, and we set that constant to 1, and we pipe that into scale, you see we're back to where we started. Again, if I just turn this on and off, you can see that even though we've created our scale attribute, there's no scale attribute to modify the incoming. It's just simply multiplying it by 1. So if we add this this random amount that we created to 1, and then wire that out to scale, turn this on, you can see that it is scaling our boxes in this area down and up relative to that amount. So it's no longer, they're no longer going into the negative. Now we could make this crazy by adding another parameter, which we will, and it could max out. We can clamp this so it can't go below 0 though. So that's kind of cool. What I'm going to do is just like we did down here when we created a position parameter, I'm going to create a scale parameter. So we're going to create another parameter that controls the scale of our scale effect. So I'm going to call this scale. Ooh, I probably can't call that scale because this is called scale. So that's important to note. This is having an issue because these two are named the same. So this is going to be scale underscore effect. Now we get our axis back here to the rest of these parameters, and I'm going to just change the label to what did I label this one down here? I named it position effect, so I'm going to name this scale effect. And it's going to be a, oops, I meant to show the label, and it's going to be another vector. And so if I hop up, now on our attribute Bob, we've got a position effect and we've got a scale effect. So if I start increasing that scale effect, you can see it starting to increase these, change the scale of these cubes. And what I can do is, you know, if I don't want any of these, if I want to protect from any of these going negative, I can just put a clamp down. So we'll go in here and make sure that whatever is coming out of this multiply, I move these over here. I'm just going to reorganize a little bit. I want to make sure that whatever is coming out of this multiply never goes below 0. Or actually, no, scratch that. I want to make sure whatever comes out of this add, where they're getting added together, never goes below 0. This multiply we do want to go below 0 because it's actually going to be shrinking things down. But after this add, we want to make sure that, you know, as the, you know, sort of last stop before it becomes the true output scale, we want to clamp it. So let's run on clamp. And clamp can actually also clamp vectors. And we just want to clamp the minimum to 0. And actually, now that I'm looking at this, I don't want to clamp the maximum, and I don't want to set the maximum to some insane value to get around this. So I'm going to just use a maximum again. So if I throw down a maximum, this is similar to how we did it when we did the fall off, right? We just are going to say we want our maximum vector to be, we want our vector to be the maximum between whatever this is and some input. And I'm going to just create an input constant here, constant, and that minimum, the minimum value we have is going to be another vector, and it's going to be 0. So I'll just wire this in here. And now, no matter what we do, everything can just go to, it can get like infinitely paper thin, but it will never go below 0 and turn itself inside out. So if I go up here and just increase the scale effect, you can see that we end up with these sort of planes and stuff, but it never really goes into the negative. So that's cool. So now if we play back our animation, you can see that it's doing, it's adjusting all of those scales of those objects according. Cool. I'm going to just bring the scale effect down a little bit. I want to just have it go to 1, 1, 1, and then let's change the position effect to 1, 1, 1, and you can see them all sort of, all of it is sort of happening at once now. So as we come in, we get all these cubes rotating off into random locations. Cool. So the next thing I want to do is I want to control the random rotation. Now it looks like we get some random rotation here by default with these. With this, the way that this is set up. But if I suppose I only wanted to affect the random rotation, and I set all these to 0. So I'm just going to right click and revert to defaults, right click and revert to defaults. I just control middle mouse button those. That would work too. See, I don't get any rotation now, even though my effector, even though my test geometry is right in the middle of this. So let's create another parameter that we can use to control the rotation effect. And now, so I don't have to get into any like really crazy linear algebra stuff with quaternions and rotations and stuff like that. The way I'm going to handle this is I'm just going to use the normal. And this isn't the same as like the true rotation that you would get if you were trying to say rotate by a certain amount in any direction, and it could rotate, you know, around and around and around. We're just going to give it sort of a random direction that it rotates into, and because when we copy this box to these points, it's going to orient itself according to the normal. So I'm gonna go and do that as well. The way I'm going to do it is I'm actually going to pre-assign a random vector to each one of these points up here, and then manipulate it inside here. So if I go after our fall off, it's fine. It doesn't matter really where this happens as long as it happens before our effector, which I'm going to name right now. Random effector. So if I go up here, I'm going to just create an attribute. Actually, I can probably just create an attribute randomize. I probably don't even need to create the attribute, because if I create an attribute randomize, it's going to create the attribute for us. I'm just going to give this attribute a random rotation name, something like rand vector. I can type random vector, which we can't see. I'm going to click on this, and I'm going to do the same trick. I'm going to hit this info button and click on the random vector attribute, which is a 3 float. And I don't see anything. Let's go down here, make sure our visualizers aren't turned on. So I'm just going to do that one more time. Info, random vector. And you can see it's visualizing this random vector using a color, which is fine. I actually want to right click on here and edit this view. And I don't want to view it as a color. I want to view it as a marker, not a text marker, but a vector. You can see that all these random vectors are pointing in all sorts of random directions. This is similar to like how you would preview a normal, but these are more or less what we could pipe into our normal attribute to get our boxes to orient accordingly. I actually want to do, let's say we could randomize this. The minimum value is 0 and the maximum value is 1. I want to do maybe a minimum value of, let's say, -1. So I'm just going to go down here until I get -1 on all of these. And now you can see that those vectors are truly pointing really in any which way. Nice. So now I have a value that I could blend between. So if I had like all of our normals were facing upward, for example, on this, I could blend between the normal and this value and sort of activate it based off of that fall off. So if I go and so we've got this random vector attribute that we created. I'm going to just turn off the visualizer for right now. And actually, maybe I'll turn it back on. And if I go in here to our random effector, and we actually need a normal so that we can actually, you know, kind of work with this. So I'm going to just create a normal as well by throwing down a normal SOP like so. And I'm going to drop this in here. And if I visualize normals by clicking this button, you can see that we actually have vertex normals that are all pointing upwards. I want to get point normals because we're using point attributes right now. Nice. So here, now, if I go into the random effector, and I'm just going to turn off the visualization of these random vectors like so by clicking that little guy. So I've got these normals here, and now what I could do is I could create a let's bind in that random vector that we created. Bind, and I'm going to type in, I think I typed rand vector. So yeah, I can see it down here in our attribute spreadsheet. Cool, random vector. Excuse me, random vector. Bring that in, and if I wire this into normal, all of our normals get messed up. Let's see, that's because it sees random vector as a float, and we actually want this to be a vector. Now we can see all of our normals are taking on that random direction that we had given our random vector. So that's cool. So now what we could do is maybe we could mix the two together. So I've got a normal attribute coming in on our globals over here. So I'm going to just grab that normal. And let's go. I just want to organize this a little bit. So I'm going to grab these guys like so and drag them up here. And maybe bring this guy over here. Again, to make those little knots like that, I'm just option clicking on my wires to sort of make those little knots so that I can kind of keep things out of the way. So I know like this section right here is modifying my it looks like position. Yeah. So I can create like a little net box around that and call this position if I wanted. So I've got this sort of organized here, and then up here I know that I'm dealing with scale, so I'm just going to bring these guys up like so, drag this off, and maybe I want to put these constants down like that. Yeah, that's good. And so this we can say is governing the scale. So we got our scale up here, got our position right here, and down here will be our rotation. So now I'll put a box around that at the end, but what I can do now is I can blend between these two vectors. So if I grab our normal, I'm going to just throw down a mix node. So we'll say mix. I want to mix the normal with the random vector that we created. And then I'll just wire this to the output normal. So you can see we've got a mix now, and we can affect the bias. So I've got a bias that is fully random, and I can bring it back to being pointing straight up vertical. Cool. So we could actually, now that we're using this mix to affect our normals, we've got this bias input. We can actually use an attribute to drive the bias. Which attribute are we going to use? We'll use the fall off. So let's grab that fall off, bring it down here, and wire it right into that mix. And you can see that fall off, I don't know why it's not lining up with our, oh, it's because I have the template flag of our geo, I think, in the wrong spot. Let's go back up here. Yeah, I want to template the transform. So now you can see that this mix is being driven by the fall off and messing up our normals wherever the rubber toy is. And if we look at the effect that this has on our boxes, you can see that the boxes are getting rotated around as well into their random places. I'm just going to turn off the normal visualization like so. So you can see that these boxes are getting all jumbled around as this guy moves through, and we don't necessarily have to displace them in order to get that to work. Nice. So down here in our random effector, I could just, this is actually pretty simple. I could just, let's just bring this mix over here a little bit, and then I just want to kind of add some knots. I just like, I don't know, it's almost like an art form in and of itself, just kind of organizing your nodes. You know what I'm saying? I don't know. I just get a little bit obsessed sometimes. So I'll just grab this stuff in a box and throw this down and call this rotation. Oh, but we haven't done, we haven't determined the scale of the rotation effect, so we got to do that as well. What I'll do is I will create another parameter, and I'll put that down here. And if I bring that over and do another multiply on this, I could do a random. This param will be called rotation effect, and we'll label it rotation effect. And I'm going to just leave this as a float. We'll just do a scalar float against this you know, that way I'm not necessarily really concerned about like restricting the rotation to a certain angle. I just want to kind of have an overall control of the rotation in a general sense. So if I hop back up here, you can see the rotation effect is 0. If I move my guy in, now I can just kind of give it a little bit of an effect. It doesn't look like it actually wants to take, it doesn't look like it wants to have only a little bit of an effect on here. It looks like it's kind of snapping, and I think I know why. Let's actually jump back into our random effector. Instead of multiplying the random vector by this rotation effect scale, I'm going to multiply the, what is it? The fall off. So our fall off here is coming through, and it is this light blue one. I'm going to just get this bind going back in to its original place. I'm going to grab this middle wire here, and I can grab this output right here, wire that in there. So, oops, I meant to wire it in right here. And again, want this effector going into that. So I'm going to be multiplying the fall off effect by our rotation effect, and just wire that into the bias. So now I'm scaling effectively the fall off amount, the amount of that variable affecting that bias. So if I go back here, I'm just gonna hit the U key to go up. I can't see anything. I'm gonna hit spacebar H to frame all my stuff. And here, now I should be able to go down and dial in the rotation effect. And you can see that it is increasing and decreasing the amount of offsetting of these cubes. Perfect. I think also at this point, now that I'm, you know, playing around with the scale effect and the position effect and stuff like that, I really kind of feel like I would want to have the scale effect be more uniform. I mean, I guess it's okay that it's okay that we've got it kind of scaling in different directions, but for me, I kind of just like a uniform scale. I don't know. So I might just add a little switch in here that allows me to kind of choose whether I want to do a truly random in all directions scale, or if I want to just do it uniformly. So let's do that. So I'm going to just dive back into the random effector here, and I'm going to call this section is going to be non-uniform scale. So non-uniform scale, and then I'll just do another section for actual regular uniform scale. So we're going to want to create another bind export. This is going to be P scale. So bind, and we're going to export P scale, and we want to, oh, this is just a bind import. I forgot. I got to do a bind export there, like so. So now I get this input here, and I'm going to call this P scale. And so we want to affect that by, let's give it a parameter that we can add to our original scale. So similarly, if we're going to be adding to a scale and we already had a scale, we know that we're going to be multiple. We're going to do it similar to how we did down here. So I'm going to just create a constant. And instead of a vector constant, it's just going to be a float constant, but we do want a value of 1, just so that we're multiplying it by 1 if we're not doing anything else. So if I wire this into P scale, it should have 0 effect, and that's good. If I were to dial this number down, everything scales down to 0. So, okay. That is working, and it's cool because P scale is layering on top of random non-uniform scale. So we can choose which one we want to do just by simply scaling up our values. So let's continue to build out this functionality. What we're going to want to do is create a parameter to control the effect of that of the scale. So I'm going to create a parameter, and this is going to be scale, and then this is going to be uniform scale effect. So we want our fall off to randomly scale our values up by this uniform scale amount. So I'm going to need to create another random integer, and I'll just bring this up over here, and I'll do a hit tab and type random again, and here we are. And you can see now if I wire random into pscale, you see everything is randomly scaled uniformly. I'm just going to add this to the original position, but I first want to fit it the way we did before. So let's fit that so that we get some scales going negative and positive. So we're just going to set our destination min and max to -1 to 1, like so, and then we'll add this to our original scale, which is 1. So just going to bring in the 1 and wire this guy in and wire that out. So now we're just adding that random scale to each one of these objects. And if you only wanted them to scale positive, you could do that as well. That would work. You could just bypass this adding step and multiply instead. So now that we're adding this to the original scale, we actually need to have the fall. We need to control it using a fall off, using our fall off attribute. So let's bring in a multiply over here. So mult. And I just want to grab the original fall off that we had up here. I'm just going to grab it and bring it up here. And I'm just going to add a little knot here by option clicking. And then I'm going to wire this into our multiply. So to make this a little bit easier to see, I want to, I'm just going to pop up here. And I want to bring down the actual scale effect that we had here. I'm going to right click and say revert to defaults, and I'm going to bring the rotation effect down just so I can see what's happening. So our scale is affecting is just randomly scaling our objects up and down in this area. And I'm going to let's see, we want to give this uniform scale effect isn't having any impact on what we're doing. So I'm just going to dive back in here, and we've got our uniform scale effect. And I think I just want to multiply that right here and add it to our multiplier. So now if I go up here, our random random uniform scale effect is having an effect. So now if I increase it too large, we're also getting negatively scaled cubes, which we don't want. So we could go back into our random effector and do another max clamp type situation here. So I'm just going to option drag this max up here, and then hold Y and drag through. And it will basically realize that we're actually only doing a float here, which is cool. And I'll do another constant. And we're just going to take the max between this and 0. And that should make it so that those cubes that are scaling down don't ever go below 0. They just shrink and disappear into just being very tiny. So now if I go in here and let's bring the uniform scale effect down, you can see that that is doing its thing there as well. We could actually modify the actual non-uniform scale effect as well if we wanted to. Up here, they're both working together. The order is a little bit off. I've got position, rotation, and I got position, scale, and rotation. I just want to reorganize this. So I'm just going to go edit parameter interface and move my scale to be down near my uniform scale. I'm going to bring it up actually and have uniform scale be on the bottom. So I've got my scale and uniform scale next to each other. Hit apply and accept. And now these guys are right by each other. So it's just easier in terms of a user interface. Another thing that I think that I might want to do is maybe we want to allow for some sort of functionality that allows the user to choose. Suppose they don't want these objects to scale up from. They don't want them to. They don't want these objects to scale from a negative number up to you know, from maybe they just want to scale in the positive direction is what I'm trying to say. So what we could do is we could actually add that functionality by, you know, maybe allowing people to determine what their min and max values are. What their min and max values are here. So where we did this, you know, suppose people want to have their objects, you know, scaling up only in the positive direction, we could actually promote these parameters to give them that kind of control. So what I'll do is I'll just middle mouse click here on destination min and promote that, and middle mouse here and say promote parameter on destination max as well. So now up here we've got minimum value and maximum value, and so if I were to you know, maybe set this to 0, you'd see that we're only scaling in the positive now. So if I crank up that uniform scale effect, you can see we're only scaling objects up. To make it even more obvious, I'm just going to bring the uniform scale of all these objects down to something really tiny. And you can see that that uniform scale is really only enlarging these objects. So what we could do is go back to the random effector. I'm just going to rename these labels something that makes more sense. So I'm just going to go to edit parameter interface up here by clicking that gear, saying edit parameter interface. This comes up and it's automatically named these parameters for us. I just want to change the labels. So I'd say up here, I'm just going to say uniform scale min, and over here I'm going to say uniform scale max, and hit enter and apply and accept. And that way these labels actually mean something. So now if we do go into the negatives, you can see that, you know, it will actually shrink down to 0. But if we bring this uniform scale effect down, you know, we just get a little bit more control. So I'm just going to say we want this to go from 0 to 1 and have an effect of 1, and then maybe actually an effect of like something crazy like that. Maybe we can add just a slight amount of random scaling to the objects as well, but not quite as much, not quite as dramatic to achieve this scaling effect. Again, if we wanted to, we could promote a lot of the fit ranges for all these other options down here as well. So I'm not going to do that, but I think at this point we've sort of achieved what we were hoping to do and sort of driven home some of the points about creating and working inside of our VOP networks. I'm just going to create another netbox around this and call this uniform scale. And we'll bring it up here and see, let's see, what else can we do? Let's just, let's offset the position a little bit using our random effector as well. Let's go with a little bit of a position like that, and maybe a little bit of rotation. So now as our little guy swims through the water here, it does it's like he's creating a little I don't know, this little, maybe a data lake of some sort that he's you know, creating waves in. It doesn't look very wavy. I mean, you could probably maybe towards the end of our animation we want to increase the distance of our fall off. So, you know, here we start here and his fall off distance is like that, and then by the time we get to the end of the animation, we'll make our fall off distance a little bit greater. And so you can see that happening and spreading across as our guy moves through. Oh, and I forgot to set a key, of course. Let's just increase that like so, and then option click in there to create a key. Yeah, I mean, that's all right. I don't know. That's just about as far as I want to push VOPs for right now. I know that might have been a little bit overwhelming. We were getting pretty deep into the weeds there, but hopefully that's a good guide that you can come back to. If it didn't all click right away, don't feel bad about it. And just, you know, come back and take a look again if you need to. So in the next section, what we're going to do is take a step back and just look at kind of a more vague concept of attribute promotion and in conjunction with group promotion and how that works. Because then in the example that comes after that, we're going to be doing something pretty cool that involves all that stuff. So stay tuned for that, and I'll catch you in the next lesson.